Hey, it's Paul Browning here. Cisco CCNA in 60 days. Version 4's on Amazon if you want to grab a copy. It matches this course almost exactly. It's got some extra bits in it. Please subscribe to the channel if you haven't already and hit the bell so you can see all our other videos and courses. So this is day 39. I should have put this in yesterday. It's hard to know what to include and exclude from the exam because they can test you on things that aren't in the syllabus. If you read the top of the syllabus, it specifically states that. So I dropped in some BGP into the paid course and GRE plus labs. So what I've done is I've added it as an option today if you want to include it. So you can review the last 3 days, any labs and theory, but also there's optional GRE. I didn't put the theory in, I don't think, but I did put BGP theory in. It's up to you. The only reason is you could be asked a question. I can't tell you what I got asked in my exam. I can't remember BGP to be honest, but it could have been in there. So there we go. There's some books will really help you get through the exam if you want to check them out on Amazon also. Other than that, enjoy the lesson. I will see you tomorrow.
Welcome to our presentation on BGP. Just to put things into perspective, after you pass the CCNP route and say you wanted to go in the BGP course, the classroom course, for example, from Global Knowledge is 5 days long. So this kind of puts things into perspective that you already need to have passed the CCNP routing and switching to attend this class, and Cisco have put this into the CCNA syllabus now. Obviously, you haven't passed the CCNA yet. So we're only going to cover what I think you need to know about BGP as far as the CCNA exam is concerned. So it's a little bit of a precarious situation because Cisco go into a little bit of the topologies and messages and configuration. However, with what you learn for the CCNA, there's no way in a million years you'd be configuring BGP for real. So let's press ahead and I'll cover what I think we need to know. What is BGP? Border Gateway Protocol. It's used to manage routing over the internet. So this is more what our ISPs or very large networks would be concerned with using. It replaced EGP in the early 1990s, if you wanted the history of it. The idea of BGP is it routes traffic between autonomous systems, and as you already know from earlier lectures, autonomous systems are networks that are under a certain administrative control, and they have all their own policies and protocols that operate inside. Now, as far as BGP is concerned, the AS numbers must be unique, and you actually have to apply for these from your whatever your government authority is. BGP forms a neighbour relationship and it's called peering with other BGP speaking routers. Here's a table from bgp.potteroo.net showing the growth of the BGP tables all the way back from 1994 to today, late 2016, and it's hit over 600,000 routes. So BGP speakers or routers pair with the other BGP speakers. They have to use a TCP connection and it's on port 179. AS numbers go all the way up to 65,565. There's a whole bunch of message types. I think I'll cover something in a moment, but you for CCNP you would need to know what all of these message types mean and what they do. For CCNA, I just think you need to know that they actually exist. Now, BGP is concerned with AS hops, not individual routers. So it's a path vector protocol. Now, an autonomous system I mentioned a moment ago represents an entire network. So we're not so much concerned with individual routers as you would be with a routing protocol. iBGP versus eBGP. eBGP is in the syllabus, not iBGP. Internal will route traffic within an autonomous system. External is dealing with traffic between bordering ASs. Network layer reachability information, or NLRI. This is how BGP supports classless inter-domain routing, so how we can summarize all of our networks to make the tables as small and as efficient as possible. They're actually part of the BGP update message once a neighbor relationship has been formed, and it lists a set of reachable destination networks. Now, BGP relies on routes passed from neighbors, so in this respect it resembles a distance vector routing protocol. The route update lists the AS numbers that the packet has passed through or must pass through to reach the destination. This actual list of AS numbers associated with the routes is called the AS path. Important to remember this actually, because the AS path update has a couple of things associated with it. The paths that the AS is, or the packet must pass through, the AS paths, and also the remote IP address. Now, if the router sees its own AS number in the update, then the update's rejected, because that means a loop would form, which obviously we don't want. And here's an illustration. You can see AS50 with an IP address here. And finally, the AS path update is received on router 6 at the bottom. And it includes the path and also the IP address. Neighbor negotiation. I think it's worth just remembering the name of the state that BGP goes through before it actually hits the established state. And the established state is where BGP peers can exchange all of the update notifications and keep alive messages, but it doesn't happen until it reaches the final state. And you can read more about this when you come to do the CCNP route if you go that far with your studies. Now, a real basic configuration, and this is stupidly basic. However, Cisco have included configuration in the syllabus, which I don't think is a good idea personally, because it's such a complicated subject that in this case a little bit of knowledge could be a bit of a dangerous thing. However, here's the configuration for the left-hand router. I've set a loopback, so BGP will set this as the identifier. 1.1.1.1. I've configured the gigabit Ethernet interface, so we've got a connection to our neighbor router, and then a very small BGP configuration. The AS number's 1. There's a couple of commands there that are turned on by default, so you may or may not see them depending on what you use. And then I've configured a neighbor manually and the remote AS as 2. And the configuration is mirrored on the right hand router, but obviously the AS numbers and IP addresses have changed. So that's all I think you need to know, and to give you a real fundamental understanding of BGP. Also read around it if you can find Cisco have got a good configuration guide and a reading guide on their website on BGP, and you'll need to follow a basic lab also. But that's all for now. Thanks for watching. Welcome to a very simple lab on BGP. I've mentioned in the theory we could be covering BGP for a week after you've done the CCNP. So you can see the topology. I've set a couple of loopbacks so we can set the identifiers, which you'll see when we issue some show commands. All the 1s on the left, all the 2s on the right, AS1 on the left, AS2 on the right. We'll configure a 192 address between the two routers. I've just used a gigabit Ethernet just for the purposes of keeping the lab simple. You'll be familiar with most of these commands. You obviously already know how to add IP addresses, but we'll just add a couple of BGP commands as we go through the lab. Just make sure you don't get any of these silly mistakes created. For example, forgetting to no-shut the interfaces. So router BGP 1 has set the AS number for this device to 1. I'll set the neighbor now that we want to establish a relationship with to the 1.2. Remote AS will be 2 when we configure it. And there's so much more we could be doing as I said, you can spend at least a week configuring, planning, troubleshooting BGP when you've already passed your CCNP. So I don't pretend we're covering anything more than we need to know to get through the CCNA exam. So over on the right hand router now, and it's the same configuration. Obviously we just swap the AS number. We've got a different loopback number, loopback address also. Show IP BGP will show us some basic BGP information, local router ID, your table version, and not much else to see because we didn't really add much by the way of configuration. Show the IP BGP summary, shows us our neighbour, the version, AS number, messages sent and received. Show IP BGP neighbours prints an awful lot of information. Only a little bit will be relevant for us in the CCNA, which you can see at the start here. Show TCP brief, you can just see our session established, our local address, the remote address, and most importantly the port 179 which we covered earlier. So that's the end, thanks for watching. Welcome to our lab on GRE tunnels. We've got a pretty simple topology here, a loopback simulating a LAN on the left, our serial link, our loopback on the right, and then we've got a tunnel interface which we're going to be configuring either side on the 10 network there. So I'll actually configure the interfaces here. I'm sure you know how to do it, but I'll add the loopbacks, the serials, make sure I no shut it. So all the interfaces need to be up. A couple of ways you can get caught out with GRE, so we'll cover those as we go along. But the 172 network is going between the two serial interfaces. If it's not a directly connected network, you need to have routes. So if you're going over the internet, you need to have routes so it knows how to get to the other side of your connection where the GRE tunnel will be ending. We're not adding any types of encryption or VPNs here. That's further along in the GRE studies, I think possibly CCNP level. Alright, so interface, I put T0, short for tunnel 0, or you can shorten it. Now you need to have a tunnel source, and you've got a few choices here actually. I've added the question mark. You can have the source as an IP address, which will be your own IP. You can have the IP version 6 address if you're tunneling, or your interface. For this example, I could have put the serial interface address, but instead I'm just going to put source serial 0/0, which is my physical interface. And it's exactly the same configuration it's the same configuration on the other side, but we need to put in the tunnel destination as well, which is the other side of the serial link. Now your tunnel interface won't come up. If you follow the example, for example, in the Cisco study guide, they've got 1111 on one side and 2222. Well, if you try and copy their lab, it won't come up because there's no routing telling you where the two network is, or the one network. So you need to be very careful if you're copying their lab. So no shut that interface. Just one thing I wanted to show you, sometimes the lab is telling you to choose the tunnel mode, but the default, which is what you'll want to leave it as, is GRE IP, which if you do the show tunnel interface or show interfaces tunnel, you'll see that that's the default mode. So we're going to do the same thing over now on router 2. Just changing the IP addresses obviously, but it's the same configuration, we just swap the IP addresses. We've completed our configuration, so we'll start off with the show IP interface brief. Obviously we need to see all our interfaces as up. If your tunnel interface is up down, you need to go into troubleshooting mode. Are you checking there's routes or your tunnel source is correct and destination? Show interfaces tunnel 0 or T0 for short. Here you can see your tunnel source and your tunnel destination. So this is a troubleshooting command. The default protocol. So it just goes to show we didn't need to add that GRE IP because it's already there. Now I'll ping across the physical link first, then the tunnel interface. The next thing we'll do is try and ping the remote network, which won't work because we've got no routing protocols or static routes configured. So just bear in mind that this is going to work the same way as any static route or routing protocol. However, we're going to be referencing the tunnel interface IP address as opposed to the serial because we're using this logical tunnel. So to get to the 192.168.1 network from router 2, we'll go via 10.0.0.1 as our next hop. Bear in mind your next hop needs to be a connected network or in the routing table, otherwise you're going to have a problem and the router will be dropped. And then we do the opposite on router 1. Back over to router 2 and we'll do a ping, and we can see we've got 100% success there. We've pinged from router 2 to router 1, a remote network over the tunnel. Just issued a show IP route for that particular routing entry, and you see there's a static route there going over the tunnel interface next hop. And then show IP route, which is going to show you the same thing anyway. But yeah, so that's the end of the lab. If you follow on my commands, you should get the same results. Thanks for listening.